Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to listen to the webinar on demand. Post-event, we will be sending out an email that includes a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our panelists, don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take about 10 or 15 minutes near the end of the presentation and go through those audience questions. And finally, as part of today's presentation, we are going to be holding a drawing for 5 $50 Amazon gift cards. We'll be doing the drawing at the end of today's presentation, so stick around and hopefully you'll be one of our big winners. All right, with that, we'll kick off today's webinar, which is the Ultimate Application Monitoring Guide for Kubernetes. Our speakers today are Chris Farrell, who is Director of Marketing, and Hugh Bryan, who is Senior Solutions Architect at Instana. Welcome, gentlemen. Thank you so much for joining me today.
Thanks, Charlene.
Thank you.
Great, great. So Chris, I know you are going to be the first person speaking, so I'm going to just put myself on mute and let you get right to it.
All right, thank you. And thank you everyone for joining us today. We look forward to showing you some really interesting ideas and concepts. And I know that Hugh has a fantastic demo put together to show everyone what we mean and how we put it to action. To start, I like to talk a little bit about how we got here. So if we think back to the good old days of 6 or 7 years ago, or maybe 10 years ago, business applications were written on probably Java, maybe .NET, and almost all of them were done as some kind of 3-tiered application where you had a web server, an app server, and then moving backwards to some kind of data storage center or a transaction system. And of course, as those applications needed to do more, be a little bit more robust, do a few different kinds of things, and as organizations tried to speed up their delivery of new applications, we kind of migrated that to service-oriented architecture, and you started to see more distributed applications. But the basic format of the things you were running, a piece of Java code sitting on top or running in a JVM, running on an app server, on a virtual or physical host somewhere, and then tied together to other Java applications doing other things, and at the end of the day, always tying back to some big, gigantic database server. And in that world, the idea of monitoring applications was actually, it was difficult at the time, but it became easier. It was all about seeing inside the Java application code and being able to tie those pieces together. Well, if we fast forward to just a few years ago, to the idea of containerized applications, what you see is a much more diverse and distributed application system. But here's the interesting part. Even though these are all running in containers, and even though you now see a couple of different application types and a couple of different technology types, you see some Python, you see a couple of different databases. It's no longer necessarily a flow of left to right from web server to app server to database. But at the end of the day, each container contained some kind of platform or app server, piece of code running inside it, and some kind of JVM or other thing, tying to other things that looked like it. So while it was a little bit more difficult to understand how all these things worked exactly together, it was still fairly easy to manage and monitor the individual parts of all these things. Now I want to fast forward a little bit to today, or even last year, or for some people, even 2 years ago, where we started to try to get, we as an industry, started to try to get a little bit more robust and controlled with our management of the deployment of these containers and the things that they're running inside them. So along comes orchestration, specifically Kubernetes. Now, what we've seen are a lot of different application pieces that we can understand what they are and how they work together. But when you introduce Kubernetes to the environment, the application. And in fact, this is even a nice, simple version of what Kubernetes system might look like once you add multiple pods and multiple nodes and multiple applications running and reused pieces and services, and some on-prem and some in multi-cloud and some hosted elsewhere. All of a sudden, you lose your ability to kind of understand how each individual piece is tied to the overall application. And in fact, in some cases, you could lose complete visibility of even the most basic pieces that you want to know about the application. Now, what I'm going to do is kind of methodically walk us through the idea of, wait, how can we reset ourselves to understand how to find an application, how to find the pieces of that application, and then how can we monitor the performance and the service levels of that application? And then, of course, the most important part of any monitoring solution, how can we detect problems and find and then fix them when we do find them? So let's talk about through the stack, right? So the first thing we always want to know about any distributed application is, where are the services running? What are they, and how are they related to each other? What does that mean? That means being able to understand the flow of any application request from one service to the next. And of course, in a distributed environment, and especially in a containerized distributed environment, every single request could go down a completely different path of service pieces, server pieces, host pieces, different containers. But we always want those different pieces to run the same way. The idea is to have a maintained quality level and service levels that meet the expectations of our customers. So first is being able to discover all those pieces. Then it's being able to understand how they're performing. The next piece is understanding if there is a failure in the deployment. Finally, if you think about, once you're running and you understand how all these things put together, if we think of that as normal state, as new pieces get deployed, can we guarantee and verify that the normal state is still operating appropriately? And as I said, the last piece of any APM solution or any application monitoring solution is being able to find where those errors are and to give that information to the appropriate stakeholder, whether it's a sysadmin or a programmer or an architect, and figuring out what was the cause of the problem and fixing it. And in this new world, of course, of continuous integration, continuous deployment, we're always on the lookout for performance optimization opportunities. So this is what we're trying to do with the discovery of the stack in a Kubernetes environment. By the way, it's really hard. What I'm showing you here is actually a service map of it. Not a small application, but this is actually a very complex application. This is actually a screenshot of the service map of one of our larger customers running their larger application. But as you can tell, it gets very complicated very quickly, and even just finding all these pieces is difficult. But more importantly is, how do we take that information or the raw data that created this map, keep it live and accurate in real time, and provide actionable results to the operations team, the development team, and anyone else, including maybe business stakeholders that need to understand what's going on with this application. Well, that's the problem that we set out to solve. I know you guys want to get to Hugh, so I'm just going to set things up a little bit for you on how we work and how we do these things, and then I'm just going to give it over to Hugh and let him go. So a little bit about Instana. We've been in operation for about 4 years. We've been selling product for 2. In those 2 years, we've been able to close out a couple of hundred customers in 20 different countries. We're built around the idea of this actionable information and automation coming from what we think of as Stan, who is our robot and mascot and does these things. We have a global operation. Our marketing team is in America and Silicon Valley. Our engineering team is in Germany, and we have a global sales organization. So that's the company. Now, what do we do? And what are all those hundreds of customers doing? Well, the way I like to describe it is, in today's world, it's not about size, it's about speed. How fast can you deploy your new applications? And more importantly, how quickly can you update those applications? So if you think of all the new development processes we've put in place, Agile, DevOps teams, microservices operations, and of course, the ultimate goal, CI/CD, and you tie that together with all the architectural shifts and new technologies that have come out in the last few years, different cloud systems, containers, Kubernetes, and orchestration. The idea is to create a much faster world, but to move within that world, your monitoring tool has to match the speed at which you're deploying your applications. So what we've done is we've created an automatic monitoring solution that handles the dynamic aspect of these containerized applications. Now, here's the cool thing. All you have to do is deploy one agent into a host. That's it. We will do the rest. We'll discover all the containers that are running in a host. We'll discover if they're orchestrated. We'll tie back all the pieces that are running in there. We'll deploy the appropriate monitoring pieces for every platform, every container, every host, and then the application code running on them. Now, here's the cool thing. We'll map all that together into an infrastructure layer, but we'll also start tracing all the user requests. So each one that comes in, we're going to capture every piece and every service it goes through, the performance of each top, and bring that back again and correlate that with all the data that we have about containers, hosts, code, platforms, etc. And then we'll do that for every single request. So in fact, we're the only monitoring solution that's ever been able to capture every single trace of every single request from the browser to the back end. So that's what we've set up. And the idea that we're doing that is to provide the right level of information, whether it's infrastructure, services, or traces, so that the monitoring team, the operations team, the DevOps team, developers, and business people can make their decisions and understand exactly what their applications are doing, even in a Kubernetes orchestrated environment. So with that, I'm going to pass it on to Hugh, because what you guys are here to see is what this actually looks like in a real environment. So Hugh, I'm going to change the presenter to you.
All right.
Take it away.
Excellent. And I'm going to share my Firefox window and put this away. So one of the things I always like to start with is remind folks what we do. We have an agent. We deploy our agent. Our agent automatically scans your environment and uses sensors to go and create a graph of the entire environment. So every component is an entity in the graph. And I just like to remember that. And that's what we started with. Instana is unique because we didn't start with like we did 20 years ago. And there was nothing wrong with 20 years ago, but we said, let's get a metric, put it on a graph, and we'll put it on a dashboard. And that's kind of the iterative process that's been going on for the last 15 to 20 years in APM. Let's get more metrics. Let's get stack traces. We'll try to stitch them together. We'll put them on graphs, and we'll present them in various ways. What Instana said was, no, let's do it differently. Let's create a re-image or an image of the environment first. So let's discover all of our hosts, all of the individual processes within those hosts, right? All the technology in the stack. And they did it. But on top of that, we weren't quite done, because that, in a sense, is really just an infrastructure monitoring system. We said then, let's monitor all of the software running on top of those environments, so we have a complete mapping of the software running on top of that environment. So now we have the software with the throughput. You can see, as Chris said, each one of those traces, those dots are actually the scale, which is kind of cool. And we are capturing those traces. So I want you to envision we're taking that software layer, those services, and laying it across our infrastructure. Now, what happens is you deploy the agent, and I've got several orchestrated orchestration-based clusters here. I've got Kubernetes is what we're here to talk about today, but OpenShift falls into that. There's other things like Swarm and other technologies, but what I really like to go through is just to review the discovery. So once you deploy the agent, we've got a Kubernetes cluster here. Now, one of the things I can do, because what we first do is discover a component, what I like to do is show everyone what that looks like and watch the sensors in action. So you deploy the agent onto the host, and the first thing that fires is the host sensor. So that's really great. The host sensor fires. And what does a sensor do? Well, a sensor figures out, it's downloaded by the agent, and what it does is it figures out what it is. Well, I'm on a host. And then what I do is I capture configuration information, right? I name myself. I give myself a name. I start collecting performance data at what resolution? Well, how about 1 second? That's pretty good. And you can see the data come in at 1 second resolution here. And then we also monitor health. And we'll do this for all kinds of technology. And you can see those here. So, for example, here's a Python app. We've got some Spring Boot applications. We've got other JVMs, an Apache web server, Nginx web server, etc. But when I pop open this, we can see now we're starting at another sensor, which is a Python app sensor. And you can see now the entire stack is discovered. So we have a host, and then we have our node, and then we have the pod, and the container, the process, and the app. Now I'm going to walk through that a little slower because I want to review each individual sensor. So again, what did we do? The sensor, we figure out what the thing is, what's the entity, we type it, we name it, we capture the data about it. And by the way, anytime any of this data changes, we flag it and update the state of the graph, because every component is an entity in our graph. We start collecting performance data and we automatically monitor it. And as you walk down here, you can see here's our process sensor. Then the Docker container sensor. Here's the pod sensor, the node sensor, and the host sensor. Now, what that allows us to do, because we strongly type things, when I'm looking at my host view here, you can see I've got my host selector for the perspective, and I can group my hosts in varying ways based on CPU, model count, architecture. But zone is kind of the default one, and zone is kind of, I like to think of it as the data center entity. But zones also have a lot of intelligence to them also, believe it or not. We'll come back to that in a minute. But now, once we deploy the software, we're going to show you your Kubernetes cluster. And what I'm going to do just for the demonstration, I'm going to filter out all the other components there, and we're just going to go to show the Kubernetes cluster, which we can do. How about this? How about if I only want to see the JVMs in that Kubernetes cluster? I could go entity type JVM. Because our software is smart, and it automatically goes through and automatically finds out the component and instruments it. Huh. Let's say that one more time, let it sink in. All of this occurs with all of our sensors. We go through, we discover all of the containers and or processes, or the processes in the containers. Then we automatically start monitoring them, monitor their health, and we start capturing traces on every call. So again, when I open it up, I've got a different application here. I've got this Spring Boot app, which is a JVM. Oh, that's nice. That's the old trusty Pet Clinic. Everyone knows Pet Clinic. We've been doing Java since 90 whatever. We have then the process, the container, the pod, the node, and the host. So we'll walk through those just a little bit slower. So here's our container data. So we have, look at all the metadata we're automatically capturing for this, right? So we're not just stuck with kind of app, runtime, process, host. We can also structure the relationship according to the technology that we're using. It doesn't have to be just this. There are other entities we can capture, like AWS services. AWS services don't run on technology that we own, for example, like an EC2 host or even a container in ECS or Google or Azure or whatever. But what we have, though, is the just the service and the performance stats. So any entity can be captured and we can render it. Also, we get down to the pod level. So now here we're in kind of the Kubernetes cluster domain. And you can see we've really got a sensor for, guess what? The cluster. And what do clusters have? They have nodes. And we have a sensor for the nodes. Again, what are we reviewing? We type it, we name it, we capture the configuration data, and we capture the performance metrics. But more importantly, or not more important, but of equal or maybe more importance is monitoring the health of everything. So just by virtue of the fact you deploy our agent, we're going to map out and show you all of the components in the environment. Now let's take a little tack here. Let's change out the filter. Let's just stick with our Kubernetes zone and let's look at the container view. Well, that's kind of nice, right? So one of the things we can do then is we can sort out our containers and group them by a number. Here we're using container namespace. We could also do it by zone. Well, we all know they're in the same zone. How about we do it by label? Now, what's interesting here is, or what's nice is that we have all of the services. They can be named, as we go in and start looking at the software, they can be named according to their container label. So now what we want to do is go from this side, right? So from this side of the house down into, or we want to elevate ourselves up to the software side of the house. So from our implementation here, we can jump right up into our services. So I'm going to jump into the service and we can see, we'll zoom back in time just a little bit. We can go right from the infrastructure component right into a dashboard on the service. Needs a better service because that's not a problem. We'll jump on over to our application here and we'll go to our shop service. So now what we want to do is look at, and again, services, a service is a service. But what's nice about our software is services in Instana are first-class citizens. And so what's really great is we start with a service. We don't have this idea of, well, okay, we've got this call, some kind of call or a transaction, and then it's kind of a nebulous thing. We actually have a service. A service is defined as an entity that gets called or calls other things. And so what we're going to do is we're going to auto-discover all of these services that are running in your Kubernetes environment. And what's really great about this is we can then show you that dependency and show you heat map based on the performance, the throughput, or the error rate. But there's always that link. We always have that link back to the underlying infrastructure that is our container-based environment. Now, getting back to our services. So now we're getting to the area of discovery for the service. And what we want to do is we want to say, hey, as we go through and discover these services, we want to understand the performance, and we capture key performance indicators that SREs always love. And so we have throughput, error rate, and response time. You'll also notice we're capturing percentiles. And as I go through and look at these, I can do a quick glance and say, hey, I've got my 50th, 90th, 95th, and 99th percentile. As I stated, we also have the flow here, and we're mapping out the flow. And all of these things, all of these services, we can then aggregate into something we call an application. Additionally, we want to look at individual, let's say we can look at another product service. We also treat endpoints as first-class citizens. So not only do our services get their own dashboards and key performance indicators and monitoring, so do our endpoints. And if we go the other direction, we can also look at applications. Applications are aggregations of services. And so here is a shop application that's made up of a half a dozen or so services. But again, what are we doing? We're automatically creating a dashboard that anyone can review and look at the throughput, the error rate, the response time. And again, at any time, we're always going to have links back to the infrastructure. So let's jump back to the infrastructure for just a second and take another look at our underlying containers. Now, one of the things I always like to show folks is the fact that of any of these containers, we can filter out whatever technology we need to look at. So we have, for example, types. I could go show me all the Node.js examples, right? So if I come down here, I scroll down, well, let me just start typing. That's a little better approach. Here's all the Node.js instances in here, all of those containers, right? Again, automatically discovered. We also have Python in our midst, right? We even have all the other languages are supported, like Ruby and Golang and PHP. And again, we have our sensors working on behalf of us. And for example, when we open this up, we take a look. Again, we've got Node.js application as a process in a container on a host. And again, this is a constant discovery, monitoring those dynamic environments and capturing all of these changes. Now from here, what we might want to do is look at all those changes, in fact. And so that's the next screen we want to look at. We can actually get in and see all of the changes in our environment. We have any change in state, whether it's a configuration on my Kubernetes environment, it could be a pod, a node, etc. We're capturing all of those things. Any application configuration. I had a customer ask me the other day, well, the job application isn't performing correctly. We did a quick scan and we found out that we found a bunch of changes on their JVM parameters. We can literally search for those because we've typed this thing out. I can go args and show me all of the events on, and pick a parameter. We'll put it in quotes, and you can do something like minus x mx, for example, or you could do how many Java agents do we see in here, that kind of thing. Now, the other thing to remember is not only are we monitoring changes, we're also monitoring sensors, and the health monitors on the sensors are all being alerted here. You can see them in the timeline at the bottom of the page, and we will be able to see them also with respect to incidents. Sorry, we'll have all the issues. Additionally, from there, each individual component will be monitored. And then, for example, here we can see we've got a memory problem on a particular host. Now, other events that we're capturing are incidents. Anytime a service has a problem, we are able to generate something called an incident. And what we'll do here is take a look at that and see what's going on. So here we have a particular incident on our particular rating service. And what it allows us to do is go in and actually review the trace on every call that Chris alluded to during the presentation. So we're able to look at every trace in that particular time frame, but also we can decide whether or not we want to look at the ones with errors or not. So I can click on this particular trace. It's a relatively simple one, but what we can see is here's a trace that came in. It's made up of 2 calls, and we actually capture details on both of the calls. If we want to go out and take in addition to this, each call is also individually captured. So when you look at this, you'll literally be able to go through and say, hey, we've got a entry service call here, which makes another call out to a database, and so forth. The other thing we can do here is take a quick look, and we'll clear our filters out, and let's look at some other traces that we've managed to capture during our runtime. Here's a really interesting example where over the last hour, we actually captured all the shop server traces. There's 48,000 of them. And just to kind of hit that home, we're able to see that those numbers will map to, I mean, they're changing every second, but they're right in there so that the dashboards are literally representing the calls that are coming in. And again, we're capturing a trace for every call. So here you can see a trace on every service call. And then you can see this trace is made up of 9 subcalls. And what's really powerful about this proposition is that each individual call is timed, tagged, and typed. You can see the type. We're going to tag it with whatever technology it was related to, and we're going to time it. Now, one of the unique things about Instana, and this is where it really kind of glues the software onto the infrastructure, is that we can, from any one of these calls, we map it right down into the stack. So at this moment in time, when this service call was made, when this service call might have been made, when this one, we're always able to link directly into the underlying stack, all the way down from the host, the container, the runtime, the process, let's say JVM runtime, and the application instance itself. We can even go one better than that. We can also kind of go the other way and say, listen, we have the ability to do queries on each and every call. And we can actually query them individually. So not only can you look for traces, but we can also query based on calls. And this is very powerful. So you can, if I clear out the filters, one of the really interesting things I can do is I can say, show me all the database calls that were going to Mongo. Are you kidding me? That's exactly what we just did. There's 5,000 of them. We can then group them by, and this is really fun, database statement. Oh, that's kind of nice. Then we can show the graphs on those. So now I see every call going to MongoDB in the last hour, and I can filter this down and down and down. But what's nice is I can drill into the individual instance and find out which trace it belonged to. So we have created a total performance analytics platform on top of infrastructure monitoring, an APM solution, a monitoring solution, and of course, we're doing analysis. There's a couple of other things I'd like to show as part of the solution in general, and that is, again, we consider services as first-class citizens. We have this idea of applications as first-class citizens. We also take Kubernetes and orchestration as a first-class citizen, in addition to Docker, or in addition to containers. And so one of the things we've added, I think everyone will be pleasantly surprised with, is our new UI we're adding on Kubernetes or orchestration. And you can see we're creating, this is just coming, it's down the road, and we have a really nice implementation of both. This works for OpenShift or Kubernetes, whatever platform you're running on. But you can see we instantly break down every cluster or namespace with custom-built dashboards for your nodes, your namespaces, deployments, services, pods, etc. And we're creating dashboards for every component. And again, these are completely curated. They don't require you to do anything. The last thing I want to mention is our website monitoring, because it's a newer technology. We've been working on this for a while, but we just rolled it out over Christmas, and I really like it. So the 3 things you care about when you're doing end user monitoring, we also have on the roadmap, we're going to be doing mobile and adding it to this capability. But what's really beautiful about this is the idea that we can very easily capture what? Your page views, the underlying resources that we care about, and then those back-end HTTP requests. Now, from here, we take a look at each individual dashboard that we've created, and we've got page views, and of course, we have our key performance indicators with percentiles included. We actually have the ability to look at where the calls are coming from, and you'll also notice filters here at the top of the page that are pre-filled in to allow you filter according to what filters that may be of interest to you. Because again, just like backend traces, we're capturing a trace on every call. The one thing I always like to show, because it's really good eye candy, is the part about geography. And so we like to throw in our 3D view of the world. It renders, and we'll show you where things are coming from. I just really like this because it's good eye candy. But again, just to reiterate, we go through, you enter your web application, you're going to capture your page views. We're going to give you a nice performance analysis with respect to page view versus response time. Then, of course, your key navigation timings. These are critical for finding, hey, is it my page? Is it a resource on the page? Is it a network issue with respect to DNS lookups, etc.? And then what is really nice is being able to get the analysis on individual resources. So how are those backend resources loading? Again, using those same set of metrics. And then also your AJAX requests. Now, how might these individual beacons or calls be rendered? Well, they're actually pretty nice. We can capture additional data along with end user data, all of the relevant information. Here are your developer tools overviews here that are really helpful. And then what I really like is the ability to link into that back end and stitch the end user call with our individual back end calls on the back. So that's been a very powerful addition. Again, the solution is Instana. I think we've got a really good, I believe it's the best in the industry, to be honest with you. And we've got a great solution for monitoring all things Kubernetes, all the software running on your Kubernetes environment, and being able to capture both from a monitoring perspective, health, and debugging. Chris.
Yes.
How was that? I think we covered most of the bases we wanted to.
I think we did. It's fantastic. I loved it. I'm a little biased, but I loved it. So Charlene, let's open up for questions.
Awesome. All right, guys. We have gotten some great questions in so far, but there's plenty of time. If you have a question for Chris or for Hugh, please go ahead and use your GoToWebinar control panel and submit your questions. We have about 10 or actually about 15 minutes to go through questions. So let's get going on them. Okay, the first one, with a three-tier app approach, you can have that approach whether you are a bigger enterprise or an SMB. So with Kubernetes, is only considerable for fast-paced, vast applications?
So Hugh, I'd like your opinion on this as the person that talks to customers and sees the most of them. But let me say something a little first. Yep. Hugh and I have actually been working with monitoring these applications for longer than I care to say on the call. And we actually have worked at several companies that dealt with everything from the monolithic three-tiered apps through SOA and now into this microservices world. Right. And actually, it's kind of interesting as the applications became more complex and more distributed, it actually opened the door up for smaller organizations to be able to build more robust applications. At least that's what I've seen. And so if you think about the needs to provide a highly scalable three-tiered application, just the system needs and the size of the systems you would have to run to be able to provide those highly scalable apps, everything from on-demand servers to platform as a service to microservices actually makes it more democratic and allows smaller organizations to provide these very high performance applications in these environments. So what we're actually seeing is the reverse, that the smaller organizations are actually able to do more in this, whether you talk about containers or orchestrated containers or microservices environment. And we see that from the business side. I see that in that both the deals that the customers that we talk to, which we have a set of customers that traditional APM tools would never go sell products to, because they wouldn't have had the ability, they wouldn't have had a scalable application that would have made it worthwhile to monitor. But today, if you and I went out tomorrow and started our own application company, we know that from the start we would have to include monitoring because the application is the company. So we're actually seeing the opposite impact. So Hugh, I'd like to hear your perspective from the feet on the ground.
So a couple of things, and these are anecdotal, but I think they're very meaningful. Number one is, don't forget that there's a couple of fundamental changes. Other than things going very quickly, remember there's this idea of DevOps. So the code is much closer to production. When we started this, code was on the other side of the world essentially, and they hurled it up over the wall, and then the operators got it and hopefully put it on a server and deployed it. And it was a giant WAR file or EAR file, or just a huge chunk of software with a million functions in it. That wasn't very democratic in a sense. It was just, it had to be all managed, and you had no visibility into it. You couldn't tweak it, couldn't do anything to it except deploy it and monitor it. That's radically changed. Now the code is closer. The environment's moving faster, but what Kubernetes, what these orchestrated environments do is allow, I think, I don't need to, in order to create a container, I don't need 5 gigabytes or all this gigabytes of technology just to make it work and test it and build it. I can build components. We've got a great example of the robot, what we call the robot shop in our GitHub. It's the GitHub robot shop. And if I come in here I'll show you an example of it. Anyone can come in here and copy of the robot shop, run it in their Kubernetes environment. I was actually, before the demo, firing up Minikube on my Mac, but I was too big of a baby to do it live because demoing that kind of stuff live is always risky. But you can see we've got a really nice microservice-based app. You can run it in that you can run in Kubernetes. We even have a Helm-based deployment option for this. But the idea is that it's one command to get it running, and we love that. So right. The applications are more interesting, and monitoring them with these environments is even easier.
All right, guys, we have a ton of questions in here, so let's move forward quickly. The next question, does the app have any intelligence or machine learning features to predict how the performance would be like based on historical performance or usage patterns?
You want me to grab those, Chris?
Absolutely. I could give a market fluff answer, but
all right. So right now we don't have. Full disclosure, inside of our software, we have 196 built-in rules for monitoring services and applications. You can see we have these ones here. So we're going to automatically monitor drops and calls, changes, increases, and all of those things, right? And we're even willing to go and show you the description of that particular automated rule. So right now what we're doing is all the software, including from the host, the process, the container, the pod, as I discussed during the presentation, every one of the sensors has its own set of health rules. But again, then all of the services and applications that are being monitored also have their own health rules. What we plan on doing, and again, this is we actually have promoted one of our PMs who is a data scientist into our AOps type artificial intelligence role, and we're looking at two things we're doing. We believe we have the right foundation to get started. We believe that since we're modeling the environment with respect to infrastructure and services and applications, we have a much better model to run intelligence against, right? To make meaningful inferences. The thing that we're doing, though, is we're going to start adding more events between the components that will kind of make this into, they're kind of, think of them as kind of event neurons, essentially. And the idea is to then run those AI algorithms against not only just the events and incidents and changes that we automatically capture, but we'll have kind of these internal neurons that'll be firing. And hopefully, in the future, we'll be able to maybe make some really good predictions. But again, that's still a little ways out.
All right, great. Next question, to capture the end user data, do you need to modify the code, or is the JavaScript automatically injected?
So auto injection is one of those things that, again, I hate to date myself, but I remember when that came and was put into the, was kind of the standard. Again, with the idea that the code is closer to DevOps, we have found that, manually putting a tiny piece of JavaScript into your code is not a big ask anymore. I would say it used to be, but we have found that, I've had no pushback at all in this role or even previous roles at other companies.
All right.
Yeah.
Awesome. Okay, next question. Let's see. How can erroneous service calls be removed from alerting, such as filtering out known noise, such as errors arising from get/Apple touch icon 120 by 120 precomposed.png? Strange.
Okay, I think I see.
I
think I got that. So there's a couple things. So you could maybe even, and we could ask the little confirmation back. What about health checks, right? So there's real errors. There's these things that are kind of erroneous, and then there's kind of health checks, I think would be fair to say. So one of the things we do have baked into the software is the ability to automatically identify both synthetic transactions or pings and exclude those from the key performance indicators of our services. So that we can definitely do. The other nice thing you have the ability to do is when I go into an analyze, remember, I can look at every single call. So one of the nice things I have at my disposal, I could say, hey, show me all the HTTP calls on a particular service, and then we could get into the weeds a little bit deeper and probably do some other exclusions. But that's a good question.
Okay. All right. Next question. Let's see. We're looking to use Docker EE with K8s. Please comment. I think it's specifically related to any performance impact.
With the what performance impact?
Well, it's so the question itself is we're looking to use Docker EE with K8s.
Okay, please right. Comment. Docker Enterprise Edition with Kubernetes.
Right.
Okay.
Please comment. But the person asking the question also previous to that submitted a question that just said, "What's the performance impact?" So I don't know if the two are related, but I'm assuming.
Hugh, if you could talk a little bit about what you've seen as far as Docker EE in the real world. I'll make a first statement about performance impact, and then I always pop that over to Hugh for a final up. Performance impact is something, of course, with any monitoring tool that you have to worry about. And when you monitor things, you of course are putting something in the middle of the whole situation. When this whole industry started, everyone would always lead with, "Oh, and we have low overhead. Oh, and we have low overhead. Oh, and we have low overhead." Here is absolutely the lowest overhead I've ever seen of any of these tools. You've actually been on the ground talking about these things. But even as you add up the stack, all those sensors, can you describe to people kind of what it would do and how we make sure we don't impact things? And then I think what the viewer's asking is, do you think Docker EE with Kubernetes is a good idea or a bad idea? And what are the monitoring impacts of that?
Right. So I'll take the last one first. I haven't seen a lot of Docker Enterprise Edition with Kubernetes. That's I don't doubt that we could make it go. I personally haven't seen it, but I'm sure we have someone in the company who has, so we can take that as a follow-up. I'm not sure how would answer it, but I don't have any personal experience with that so far. I've done about 100 different Kubernetes environments, all told, and all over the place. I think that's what I've totaled so far. With respect to performance, here's the way I like to characterize it. Number one, and I'll give a lot of real enterprise APM companies a credit. If they are telling you their software is designed to run in production, then they mean it, right? I don't want that's going to matter. And if they don't live up to their promises, well, then you can do with that what you will. What I like to say is this: is that since in my 2 years here, my personal experiences, I've had maybe one issue, and it was just it was an instrumentation thing that we ultimately fixed. Here's the big deal for orchestration environments, since what we're talking about. What we like to say, and what our founder likes to say, is if you've got a 64 core machine or a 32 core machine, give us a percentage of one of those cores. It's going to vary based upon the number of containers. Other than besides that, the way we designed our agent is it's actually a tiny, really lightweight runtime environment that manages itself. And so we literally have the ability to change run levels in flight to make sure there is no impact on the application. And so there's with our German engineering, which I always like to highlight, we have a lot of safeguards built into our agent. And again, we always welcome people to try it out for themselves. And let me throw an anecdote on the end. I would have no problem taking our software into a production environment, given the right circumstances, and putting it in there and having it run. I've been doing that my whole career.
Okay. All right, great. I think we have time for one more question here. So the question is, I'd like to learn more about the capabilities of tracing low-level network stuff like DNS lookups, especially in Kubernetes. Can you show an example? I don't know if you'll have time for that, but and then he says, great system, by the way, much love from Germany. So there you go. Germany loves you.
No, gotcha. So there, right now at present, we don't do the kind of networking breakdowns that he's asking for, he or she is asking for. I will say this, it is typically when you have a series of traces, when network problems come up, the nice thing, here's what we have though in our back pocket. So when you drill into a particular component, having not only the response time of the software here, right? We can see if we can see the two calls here that make up this call, but you can always drill. You have the timestamp, and what we can do is drill into the underlying component at every level to see what the performance could be. 5 minutes either side of when that trace called. And so what you have is you have the ability to monitor the runtime component, the JVM, the process, the container, and even take a look at the host itself. So during that same time frame, and try to figure out what inference you could make. But we don't have a specific instance to nail down. Oh, this DNS call took this long. But I'm sure we could figure it out given enough time. I have to think about that one a little bit.
Okay.
Yeah.
All right. Well, unfortunately, that is all the time that we have for the questions. If we didn't get to your question during today's presentation, I'm very sorry, but we are going to, we have all of the questions here in a list, and the folks at Instana are going to get a copy of all the questions. So I'm sure somebody from the organization will be more than happy to follow up with you offline to get your question answered. So at this point, I would like to go ahead and do the drawing for the 5 lucky winners of our Amazon $50 Amazon gift certificates, or gift cards. So drum roll, please. Our first winner is, let's see.
It's Chris Sparrow, right? Chris Sparrow.
Yeah, it's Chris. They're all Chris. No, first winner, Anant Agrawal. Congratulations, Anant. Second winner is Christian Doug, D-U-G. Congratulations, Christian. Third winner, here's an easy one, Eric Roberts. Congratulations, Eric. Next winner is John Wick. Congratulations, John. And our final winner is Tracy Cisneros. Congratulations, Tracy. We'll be following up with all of our winners offline to get the gift cards over to you. So again, congratulations. Want to remind the audience that today's event has been recorded, so if you missed any or all of the event, you will be able to listen to it on demand. We are going to be sending out an email a little bit later on today that includes a link to access the webinar on demand. The webinar is also going to be on the devops.com website, so you can always look for it there. Just go under the webinar section on the homepage and look under on demand, and it should be right there waiting for you. Chris Farrell and Hugh Bryan, thank you both so much for such a great presentation. So many questions came in. I know a lot of folks got a lot out of it, so thanks very much.
Thanks, Charlene, and thank you everyone for coming and listening to us today.
Yes, thank you to the audience for joining me today. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.